Welcome back to lesson 1.6, the video on functions and composition. Clip 1 covered composition, but now we're looking at clip 2, which is covering how to decompose a single function into two functions. Or rather, how to create two functions that when we do f of g of x, we get the original function that they gave us back. So we did an exploration with this, which hopefully set most of you up that you should be pretty good so far to understand it a little bit. To decompose a function is to be able to pull the composition apart into two separate functions. These functions need to be figured out so that when you're trying to create your own f of x and g of x, that when it is composed as f of g of x, you would get the original equation. So you are building, or not necessarily building, but figuring out f of x and g of x so that f of g of x equals the single equation you were given. Let's take a look. Oh, and when you're doing this, there's this hidden rule. F of x, and actually it's not all that hidden, we just don't have it written down here, and g of x cannot be the function x. Because obviously if I just said, oh, make it x and make the other one this thing, then I just plug it in. This is called the identity function. So you might see your textbook say that the two functions you use in your decomposition cannot be the identity function, which is just x. So when I look at this, I'm looking at operators. I'm seeing overall I have a fraction and I have something being squared. Sometimes this may have even started as a polynomial expression. Perhaps it started out as x squared plus 4x plus 4, and I factored it to this to help me build my two functions. So if it had started with this in the denominator, I would have done that, but I don't need that right now. All I need to recognize is there's one thing, 1 divided by something squared. So that's the bigger operation. The x plus 2 is what's being plugged in. So I'm going to say x plus 2, what's being plugged in is the x plus 2 and the operations that happen to this are 1 over that, which we're going to call that x squared. 1 over something squared, 1 over x squared. So what I need to do then is actually check this on a sheet of paper to make sure that it does work. So I'm going to check this. F of g of x. I have people all the time who on their quiz give me something crazy, or they might even do the reverse. They might switch these by accident. If they would just plug it in, they'd see, oh, I have it reversed. I need to make this f and this g. So this is going to be 1 over x squared, and I'm plugging in x plus 2. Oh my gosh, it's the same function. We found two functions that when you do function composition, you get this single function. That's called decomposing the function. There are some other things that you could have come up with to make this work, but this is probably the simplest one. When we have something like letter h, which is a polynomial function, the very first thing I always try to do is factor it, because that can often help. So I've got 3 times x squared minus 4x plus 4. Some of you might just stop here and say, whoa, look, I've got 3 times something. That can be the bigger function. And I've got my other one, the one that I'm plugging in, is x squared minus 4x plus 4. It's perfectly acceptable. When you plug this in, you get this back if you distributed the 3. You don't have to stop there though. This is actually a perfect square. This is x minus 2 by x minus 2. So really we have 3 times x minus 2 squared. So someone else may come up with this and say, let f of x equal 3x squared, 3 times something squared, and let g of x equal x minus 2. That's fine. Both of these answers work because when I plug this in here, I get this and I distribute it and get this. When I plug this in here, I get this. When I expand that and distribute the 3, I get this. So there's more than one answer possible for some of these, but you always want to go back to plugging it in to make sure it works, that you didn't mix it up somehow. In this next function, h of x is the square root of 3 over x plus 1. So I see a couple things. This is tricky because there's a binomial in the numerator and a binomial in the denominator. But my two major operators are square root and division. So I'm going to start out with my f of x being the square root of something, I don't know what yet, divided by something else. We're going to have some numbers up here. At this point, you have to pick whether to lock your denominator or lock your numerator and keep it as is. There's probably infinite possibilities that you could come up with to do this, but this is one of the simplest ways that you can do this. I'm going to choose to lock the x plus 3. So if I'm locking my x plus 3, I hope I'm doing this right. I'm not done building f of x. We're going to have something over here, and I'm just going to put it over x. In the end, what I'm doing is my g of x, right, the number that has to go down here, get plugged in here, has to be x plus 1. Well, if that's x plus 1, here's why it's so important to check. If I do this, I have square root of x plus 3 over x plus 1. Like, that's not right so far. Well, this part is. When I plug this in, that bottom's exactly what I want. Unfortunately, the top becomes a 4. I don't want it to be a 4. I need it to be x plus 3. So if it becomes x plus 4 under that radical, then I have to change this slightly. If I need it to be a 3, then I need to take 1 away to make that become square root of x plus 3. So from this, that's what I'm adding right here. I'm going to have to take 1 away from here. So this is going to have to become that f of x is the square root of x plus 2, and my denominator is x, and g of x is x plus 1. Now I'm going to check this, right? I've got square root of x plus 2 over x. That's what I have here. I'm plugging in x plus 1. In doing this, this gives me the square root of x plus 3 over x plus 1. So how did I do that? Again, I started with locking that numerator and saying, well, I'll just make x the denominator. X plus 1 is what I would plug in. But if I plug x plus 1 in here, then I get a 4. So to make it go back to 3, I have to take 1 away. It's actually this value that I have to undo. An alternate way to have done this problem, so this is or I could do it a different way. I could have said, let's make this x and lock this denominator. In this case, if this is my f of x, then what I want to plug in here for g of x is x plus 3. So as I do f of g of x, I have the square root of x plus 3, yay, that's exactly what I want, over x plus 3 plus 1. The problem now being that down here I have x plus 4, which is not what I want. I want it to be x plus 1. So I have to take 3 away from that denominator in my original f of x, which would give me square root of x over x minus 2, and g of x being x plus 3. When I plug it in, I've got the square root of x plus 3 over x plus 3 minus 2, which becomes x plus 1, the original function back. So there are multiple combinations you can come up with. Those are two of the most basic ones. Let's look at these last two examples on decomposition. Letter H. I have I can't use x, so this one's going to be a little tricky down here. I have a function that has x plus 7. So I'm going to say let f of x equal 1 over x. So I see that major operator is 1 over something. Now there's multiple things you could do with this too. but that's what I'm going with, and let g of x equal the x plus 7. When I plug this in for x, I get 1 over x plus 7. And our last one, the major operator I see is the square root and the division of 3. You might choose to do it differently. I'm going to make f of x the square root of something divided by 3. The something that I'm going to plug in for x is going to be x minus 1. And once again, you need to double check this. Plug it in as x minus 1. Sure enough, square root of x minus 1 over 3, we get the original function back. So the two functions that I decomposed this into work. Because f of g of x, f of g of x equals that original function. This concludes our video for decomposing a function. It gives you several examples. You really are going to only get good at this by doing some, trying some, checking them, and then if you're struggling with this a little bit, you can watch this again or come back to see me for some extra help with it. This completes the learning targets for 1-6. Again, the first one was in your summer packet, performing operations of addition, subtraction, multiplication, and division with functions. The first clip that we watched the other day was finding composite functions and state the domain. And now we've looked at how to decompose a single function into two functions. Have a great day.